now I'd like to spend just a little bit more time looking at examples. So to continue with examples that we have seen before, let's consider a situation in which, again, we want to find the interval of convergence for a power series. In this case, let's look at the power series which sums from k equals 0 to infinity, 4x plus 1 raised to the k over square root of k plus 1. So to begin, I would want to use the ratio test on this series. So I would take the limit as k approaches infinity of 4x plus 1 raised to the k plus first power divided by the square root of k plus 2. And then I would multiply by the reciprocal of the kth term, giving me square root of k plus 1 divided by 4x plus 1 raised to the k. In this instance, I would get an extra factor up top of 4x plus 1. If I bring that outside of the limit, I need to include the absolute value. And that would leave me with the limit of root k plus 1 divided by root k plus 2. This limit is going to approach 1. This will leave me with the absolute value of 4x plus 1. If I'm using the ratio test to decide on convergence, we want to know when this limit is strictly less than 1. Recall that my goal here is to end up with a situation in which on the left-hand side I have x minus the center, and whatever is left over here would have to be the radius. However, what I've written this in the current form here, this is not of that form. So the center, which is the value of x that makes this power series evaluate to 0, that would be negative 1/4. So that's my center here. So what I can do is factor out a 4 in order to get this x minus the center. And I can then divide both sides so that I can isolate the absolute value of x minus a. What we get from this is that the radius of convergence here must be 1/4. So let's think about what that means about the endpoints of our interval. Again, at this point, I know that the center is minus 1/4, and we know now that we can go out by 1/4 to the left and 1/4 to the right. Going to the left would yield minus 1/2, and to the right would be 0. Those are my endpoints. At this point, I know that the interval has to include everything between minus 1/2 and 0. However, we don't yet know about what occurs exactly at these edges. So checking the endpoints, I plug each one in turn back into my power series. Doing so with x equals minus 1/2 will give me 4 times minus 1/2 plus 1 to the k divided by square root of k plus 1. Now, when we plug that in, notice that 4 times minus 1/2 is negative 2, and I'm adding 1. So that's going to become a negative 1 in the numerator. So I get an alternating series. So I can apply the alternating series test, which would have me look at the limit as k approaches infinity of 1 over square root of k plus 1. That's certainly 0. Likewise, looking at the size of the terms, I can see that they are in fact decreasing. 1 over the square root of k plus 1, of k plus 2 is strictly less than 1 over the square root of k plus 1. Both of my conditions hold, so this series converges by the alternating series test. Going to my other endpoint, x equals 0, if I were to plug that into the power series, that's going to give me 4 times 0 inside here. And simplifying that, the numerator would reduce to 1 to the k. And I can, of course, write that as just 1. As we saw in an earlier example, this is really written in a certain way because the index k is starting at 0. This is the same thing as if I started at 1, and instead of the term being 1 over square root of k plus 1, it would be 1 over square root of k, which I'm going to write as 1 over k to the 1/2. doing so, I can recognize this is actually a p-series. So right away I see that it diverges. And to justify that, again, I want to reference that it is a p-series. And in particular, the value of p is less than or equal to 1. So putting this together, we have an instance where our interval now includes one of the endpoints, but not the other. So here we want to include the minus 1/2, but exclude 0. So again, we've seen examples like this, but I wanted to go through in full detail one more case where we had to really look and check those endpoints. Now to look at an example that's a little different from anything we've seen, this is focusing more on the concept of the interval of convergence and the radius. And suppose here then that we have some general power series. So we don't know what the coefficients are, but I have a power series with terms c sub k, x minus 2 to the k. And you're given that this power series converges at x equals 5 and diverges at x equals negative 3. With this limited information, we're going to be asked to, for each of the following, determine if the series must converge, must diverge, or that there is not enough information. Okay, so we don't know what c sub k is, so we don't have complete information about the series, but we are told a little bit. So let me think about what we do know here. I know that the center of this power series is 2, looking at the structure. So thinking about the number line, we know that it automatically converges at 2. But we're also told that at x equals 5, that this converges. And at x equals minus 3, this diverges. So we actually know quite a bit from that information. So to begin with, we're given that we have convergence at 5. One thing that we automatically get as a result of that is convergence everywhere between 2 and 5. So the way that the radius works, or the interval I should say, is that it's continuous here. So I couldn't have that it converges at one point and then a point further away it diverges and then it converges again. So as soon as I know it converges at 5, anywhere between 5 and the center must also converge. The other thing we know is that the radius is a symmetric idea. So we look at the distance from the center both to the right and to the left. So as soon as I know that this converges 3 units to the right, if I look at 3 units to the left, which would take me to, minus 1, then I know that this power series has to converge between minus 1 and 2. Then, considering the point of divergence that's given, we know that this series diverges at minus 3. And what that means is that as soon as we hit minus 3, we're far enough away from the center that we're guaranteed that this diverges. That means that anywhere further away from the center would have to diverge as well. So we know that we have divergence everywhere over here. But again, let's think about the symmetry that's involved here. I can now notice that that is 5 units to the left of my center. So I can now look at 5 units to the right, which would take me to x equals 7. Because of the symmetric nature of this interval around the center, then I know that anywhere beyond 7, I'm going to get divergence. So there's one last thing to consider, though, is intentionally, I've tried to demonstrate some kind of openness here. So if I come back and look at, there's 2 points where we really don't know anything. So consider the point -1. I'm going to put a question mark here. So I can see oftentimes it's confused that we must have convergence there. But we don't necessarily have to, because consider a situation where my radius of convergence is 3. Then it's possible for my interval to include the right endpoint 5 and potentially not the left endpoint, or it might include it. So it could converge or it could diverge. So I don't have enough information to say anything about that point. And that's the same reason that I likewise don't have any information about x equals 7. It's possible here that the radius of convergence is 5, and it just so happens that the left endpoint is not included in the interval. That wouldn't tell me whether or not we have convergence at the right endpoint. And then finally, I'll point out that this portion, these little intervals between 5 and 7, and from -3 to -1, we likewise don't really know anything about what happens there. We don't know if the radius is as small as 3 or as large as 5. It really could be anything in between. So this is all just kind of pre-work, thinking, what do we know given the description above? This is going to help me answer the questions that are asked here. So for each series I list, we want to decide if it converges, it diverges, or we really don't have enough information to decide. So the first one is the sum from 0 to infinity of c sub k times 8 to the k. So my goal here is to try to place this at a certain value of x on my number line. To do that, again, I want to come up and remember this format of my series here. So of course the c sub k is the same. I have the same starting value of k, the infinity up top. So what I'm trying to identify is how we can view 8 to the k as x minus 2 to the k. And that would happen if x is 10. So what's helpful here is to identify, to get this series, what value of x was plugged in. We decide that it's 10, and now I can look at my number line. So 10, right, is in this area, this known area of divergence. So noting that this is corresponding to x equals 10, I know that this series has to diverge. Again, I can do a similar approach if I'm looking at the sum from k equals 0 to infinity of c sub k. Notice that in order for this to have come from the power series, we have to have plugged in an x value. And thinking about the fact that I don't see anything here, this is times 1, which I could think of as 1 to the k. So 1 to the k is technically what I could envision multiplying by c sub k. And we're trying to match that up to x minus 2 to the k. And that would imply that x is 3. I find 3. 3 is here. And again, that falls into my region where I know that the power series converges. For part C, we could consider the situation in which I have the sum from k equals 0 to infinity, c sub k 4 to the k. And here, again, we're taking 4 to the k, matching it up to x minus 2 to the k, and seeing that this would be x equals 6. So x equals 6 falls into this region where we don't really know what happens at that series. So this would be an example where we have not enough information. Consider D, which is the sum from k equals 0 to infinity of negative 1 to the k, c sub k 6 to the k. So here we have to be very careful. This does not mean I need to look at my power series and try to match up x minus 2 to the k to 6 to the k, because this is really c sub k times negative 6 to the k. So I have to really notice that first. So it's really negative 6 to the k that I'm equating to x minus 2 to the k. So my x value here is minus 4. Minus 4 falls into this region. And so we know here that this would diverge at that point. And then finally, consider the sum from k equals 0 to infinity of c sub k times 5 to the k. We're trying to take 5 to the k and equate it to x minus 2 to the k, which would give us x equals 7. And notice that puts us at a potential endpoint. We don't know. But we already discussed here that even though that is equidistant from the center as the same as -3, that knowing that the series diverges at -3 does not tell me anything about the series at 7 in this case. So this is another way that we could fall into a situation where we do not have enough information to decide.